Hello guys, welcome back to Java Devs. Today we are going to look at yet another interesting topic in the Java world, which is about method resolution. And this is going to be a detailed explanation of how the compiler actually resolve to a method invocation. This is normally called method overloading. However, method overloading is one of those topics that look easy, but they actually are not. And most developers, you find that they are not really aware of what's going on under the hood for a compiler to end up choosing a specific method. So there are many rules that you must know that applies to method resolution. So without wasting time, guys, let's get cracking. As you can see on the screen, we have a code snippet that we're going to try to see how it goes. But first of all, I would like us to try and compile it and see whether it compiles or not. Okay. Oh my god, yeah, it does compile, guys, as we can see. So the question that I have for you guys is, you can try and pause this video and try to come up with the output for this code snippet without coding it. Yeah, and see if you will get it correct. So okay, I'm not going to run the code. We are going to explain it first, then we will then run it at the end after we have explained it. So I'm going to start with the first line, which is this one, edu 1 true. So when we call this method, okay, for now we can pretend we don't have all these method invocations here. Let's assume we just have this for now. The question is, which method will the compiler call? That's the first question that you must answer. Which method will the compiler call? So the first thing that you have to understand is the first rule of resolution is that the compiler will look for the exact match. By exact match, I mean in terms of argument. So here we see we have primitive int. We know every literal number, when you declare it in code like this, it's by default an integer, an int, sorry. Yeah, it's pretty much the same thing. It's an int. And we have here as a boolean, all of which are primitives. So the compiler will start first by looking for the exact match, which is it will try to look for method edu that takes an int and then takes a boolean as an argument. So we see that this code, first it passes two arguments. The first is an int, the second is a boolean, both of which are primitive types. Then you must notice there is no function with the signature that match the types and the number of arguments passed. As we can see here, guys, we do not have a method that takes int and a boolean. So now I have already mentioned that the compiler, the first thing it does, it finds the exact match. And if it doesn't find the exact match, it will do what we call type promotion if the arguments are primitives. If after it has done promotion, still there is no match found, the compiler then auto-boxes the primitive. And if it doesn't find the match, Then the last result is to call a function that takes variable arguments. So now, variable argument, guys, also known as varargs, as well as autoboxing, were introduced in Java 5 in 2004. And as we all know, Java 5 is considered a major release in the Java community or Java history of version of Java Java releases. It got very nice features, some of which are generics, annotations, enhanced for loop, static imports, things like big decimal, autoboxing, unboxing, concurrency utilities, and many other good features that you see today. But one of those interesting things that Java 5 brought was generics and annotation, which stand out, and like they revolutionized the way we code Java. That is why I sometimes like to call today's developers annotation generation. Um, so varargs, guys, or varargs provides a shorthand for methods that support an arbitrary number of parameters or of the same type, meaning a method that can take any number of parameters that are compatible with the type that is specified. So now, before I proceed with the varargs, I want to touch a little bit on the issue of type promotion. Okay, let's come here, guys. So we see here we have, sorry. So we see here we have get, and we passing one, which is primitive int. But here we have long, which is a wrapper. It's not a primitive. So the question I have for you is, if I compile this code, will this code compile? Think about it for a moment. Alright, so this code will not compile. So if I say examples.java, this code will not compile because we stated that the first thing that the compiler does, it looks for an exact match. So there is no method that takes an int as an argument. The second thing that it does, it will promote that thing, this int. So type promotion is when you increase the scope of your variable in terms of bits. For instance, a byte promotes to a character promotes to an int, a short promotes to an int promotes to a long promotes first to a float, then to double. Then float promotes to double. That's what type promotion does. This is done by the compiler for you automatically under the hood. So when we promote int to a long, we still can't find a long, which is a primitive. Then we promote that again to double, we still can't find it. Then we have reached the end. Now, after doing promotion and we still could not find a match, we do what we call autoboxing now. So we will try to autobox this. So when we autobox an int, we get integer, but we still can't find a match. Then the last resort now would be variable arguments. So we have already seen that this does not compile. So if we had this scenario, we have int variable arg I'm just going to put I here. I'm going to copy this and put it here. So if we compile this code now, it compiles because it will find a match. And if we run it, it will give us int I, which is variable argument. But let's assume we put, because we said the first thing that happens is promotion before we even get to variable argument. So I'm gonna copy this method and put a double here. I'm gonna put D, so double D. So we want to see which method will be called. So based on the explanation I have given, double should be called. This method should be invoked because of promotion that happens before we could get to the variable argument option. So let me compile this code and then let me run it. So we see that this time around we get double D. So now if I put integer here also, now this is what we call auto boxing, and it also happens before variable arguments. So that means we're going to get integer. We're going to get integer I as well, even in this case. So let's run this code. Get integer I. So guys, we have proved about the rules of resolution. So now let's come back to our point of discussion now. I'm gonna bring back this. So we have already proven the first the first rules. So now, given this scenario, we see that we don't have an exact match. We did promotion, it becomes a double, still we don't have an exact match. A boolean. So what do we do now? The closest match to this is, this will be auto boxed. This will also be auto boxed. So the resulting invocation would be integer, comma, boolean. This is the resulting invocation that we will have. So we see we have integer, boolean. So now the question is, what will be called? So we know that every wrapper is by default, or it implicitly inherits from object class because it's a class. So that means this should be compatible with each one of them after auto boxing should be compatible with objects. Now then, so that means we are going to land into this method called object, which is a variable which takes variable argument of type or object, because each one of them is an object, so it will actually be able to it's actually compatible with this method call. So the closest match now is the function that I have just highlighted here, and we have shown that this is the original invocation which gets converted to this. That is what we have actually shown. So this is the method that will be called. So now let's proceed to the second one. What will this result in? So we should remember that variable argument provides a shorthand for methods that can take any number of parameters that are compatible with the type specified. Any number implies 0 is also permitted. Yes, you can call a method that takes arguments as it variable arguments as its arguments with 0 arguments. Of course, you can't have negative arguments, guys. It makes sense. So now this means a method edu can call either this method or this method. We have two now. Now the question is, which one will the compiler choose, because they are both eligible for selection. To help you understand how the selection happens, I'm going to give you guys an analogy. Assuming you arrive at home, you're holding just one slice of bread, and you find a mother and the child. They are both there, very hungry. The question I have for you is, between a mother and a child, who are you going to give that slice of bread? Typically, you would give the child. So the compiler works exactly the same way. It will choose a subclass or a child over the parent. And we know, guys, that object class is the top in the hierarchy, and everything else falls just below it. So every class is inheriting from object class. So now that means Stack Overflow error is a subclass of object. So now it should make sense that the compiler will have to select Stack Overflow error because it's the child of object class. There is a hierarchy of classes that you have to know. You have to know that, especially with threads, sorry, especially with errors and exception. At the top we have object, below it we have throwable. Then throwable has two subclasses, which is error and exception. Exception has many subclasses, and the hierarchy is just too much. I will not go into the details of it. Then error also has its own subclasses, which is virtual machine error, IO error. Then virtual machine error has what we call out of memory error and Stack Overflow error. So you see that Stack Overflow, although it's not a direct subclass of object, there is that hierarchy that you should be aware of. So now let's come to this method call. As you can see, we are passing in an array of ints here. And guys, you all must know, or you all know that, let me just take out this. An array is implicitly an object. There is many ways to prove that, but I'm not going to go into the details of it. So having said that, it should be obvious that the question now is, which invocation will be called? We see we have object, we have variable argument. So another thing that I forgot to mention is that variable argument is a form of an array. That's what they always say, because even the way you access the the values in that list, it's pretty much the same way you access them with an array. Of course, we say it's a form of an array, or you can say it's compatible also with arrays, but of course the array type must match the variable argument type. In this case, we see it's of int, and arrays of ints, arrays of object, they are sorry, we can say they can be compatible. So some people, when they describe that, they would say variable argument essentially take a list of arguments and convert them into an array. Why? Because you can operate on a variable argument the same way as you do operations on an array. This is very similar to REST operator in JavaScript, to those of you who are JavaScript developers. So now, not only does it match arrays, but also a collection or a map. But the collection or a map must match the type, variable type specified. That's basically it. So the reason why I mentioned the issue of array of ints being compatible with array of object is because you can have this statement, and this statement is valid. Or like when I said an array is an object, it means this statement. Sorry guys, I was mixing the two. It means object O equals to new int is a legitimate, valid Java statement that will compile. So now, the closest match for the function call new int is a function with a signature object array, and therefore this would be the output. Alright, let's proceed to the next one, guys, so that we don't have to waste more time. Sorry. So now, to understand this one, first we have to understand what 1L means or does. So this thing tells the compiler that you want the type to be a long, which means the one passed as an argument is of type long. Note that the long here is primitive and not a wrapper class long. Now, what the compiler starts to do is to first look for the exact match. It doesn't find the exact match because this long here is wrapper, is not primitive. And now what the compiler does next, after it has failed to find the exact match, it promotes a long to a higher type. So now it will promote it to a float first, then there is still no float. Then it promotes it to a double. Then there is no double. Okay, let me do this. Yes. Then it doesn't find, yeah, it does find a double. After it has promoted first to float, then it does find a double. So that means this method call will actually call this instead of this. We have already proven here those roles. So yeah, that's it, guys. And with this method type promotion thing, for you to be able to understand, you must first know the type, primitive, and the number of bits, so that you know that a higher from this bit, from this type, we promote to this type. We have already mentioned that byte promotes to char, character promotes to int, short promotes to int promotes to long, Long promotes first to float, then to float, and float promotes to double. Yeah, guys, that's it. Then now we come to this one here, where we are passing just one as an int. So we see that the compiler takes 1 as an int by default. So by default, every non-floating point number is an integer. So the compiler does a search to look for an exact match. So we are going to look for a method that takes an int, and we don't find it. What do we do if we don't find an exact match? What do? We promote. So we promoted an int to long. We don't have a long. We promote that long to a float. We don't have a float. We promote that float to double, then we find a match. So that means it will call this method again. Then we come to this one, which is the second to the last. And we know that the double dot value of 1, it will return a wrapper. So you give it a primitive, it returns a wrapper of type double. It returns a double instance representing the double value specified. So now double is of type object because it's a wrapper. It's a class, so implicitly it inherits from object. So now the compiler also tries to find an exact match by trying to find a method that takes double wrapper as a parameter, and it doesn't find it. So what does the compiler do next? The compiler does what we call unboxing. So remember we mentioned that Java 5 added autoboxing and unboxing. So the compiler will unbox this double to its corresponding wrapper, so the primitive type, which is double. So now that means this method will be called again. So it looks like this method is always the match because of unboxing. So guys, now we come into the last invocation, last call. So in this one, the definition for it is the same as the other one in line, the first one in line, let me see, that's line 5. Yeah, definition for this one is the same as this one. First we look for an exact match, we don't find, which is int. After that we try to do promotion, we still can't find anything because this one takes two arguments. And then after that we do what we call autoboxing, in which case we're going to have integer. So we're going to have this. So guys, we know that this will eventually come here. We have already explained that part. So guys, I hope it was an interesting session for you also to watch this, where we went to explain how the compiler does resolution, how method overloading actually works under the hood. Now you know all the rules that follows: promotion, autoboxing, unboxing, and where the variable arguments come into place. Thank you guys for watching this video, and please don't forget to subscribe. See you in the next video.